This is Precalculus homework 3-6, inverses with logarithms and exponents. Let's jump right into this. We're trying to find the inverse of each function. Whenever you're doing the algebraic inverse, all you're supposed to do for your first step is switch your x and your y. So this is going to read x is equal to log of y. I don't know why I wrote an equal to sign there, plus 7. I just switched my x and my y. And then from here, technically that's in parentheses, but you don't really need to write that. I need to get rid of this plus 7 first, so I'm going to subtract 7 on both sides. I'm going to get x minus 7 is equal to log of y. Man, the desk that I'm writing on is like super wiggly. Hold on. Let me choose a different desk. This desk. Sorry for the noise. There we go. This desk is not so wiggly. I'm over at the elementary school right now. Then from here, this is technically log base, and I'll do a different color here. This is log base 10 of y. And the base I'm going to choose for my exponentiation is I'm going to choose 10 for both of these. So now I'm going to kind of cheat here and erase this equal to sign and move it down a little bit. And this is really now 10 to the power of x minus 7 is equal to 10 to the power of log base 10 of y. We have exponentiated the function, and on this right side, 10 log and 10 are gone. This y is going to come down here. Really, this is asking a question, right? What power does 10 need to be raised to get to y? Well, 10 need to be raised to that power to get y. Whatever the answer is, that's how it works. So whatever's on the inside of the parentheses is going to be untrapped. And this is just going to be y out here. And then I'm just going to rewrite the left-hand side, 10 to the power of x minus 7. That was not the best 7. There we go. And I'll box my final answer, and we will check our answer. There it is, 10 to the power of x minus 7. I don't know if I explained this well enough, but whatever that base is, that's the base that we choose for our exponentiation every single time. What about for number 2? Again, switch your x and your y. So this is going to read now x is equal to 7. I forgot my L. Usually I do a cursive L so I don't confuse it for 10. Log base 10 of x, technically. I need to get rid of this 7 first. Everything that's on the inside of the parentheses, like down here, this you can't get rid of until you're done undoing the logarithm. But this 7 is on the outside, so I can undo it first. I'm going to divide both sides by 7, and I get x over 7 is equal to log, technically base 10 of x. You don't have to write the base 10. You should just know that that's base 10. And then what do we exponentiate both sides with? With a 10. Because, again, you're choosing the same base 10. You can say it's 10 to the power of log base 10 of x is equal to 10 to the power of x over 7. And, again, you can kind of show your work by saying cross, cross, cross. And you get, did I? I've done this before. I didn't change that to a y. I changed that one into an x, but I forgot to change that one into a y. My bad, my bad. All right, let's go ahead and fix that. This is now a y, and y is down here by itself is equal to 10 to the power of x over, it's supposed to be a fraction, 10 to the power of x over 7. Let's go ahead and check our answer, 10 to the power of x over 7, 10 to the power of x over 7. We got it. All right, number 3. Again, switch your x and your y. What do we got here? We get x is equal to natural log of negative 4x inside the parentheses. So what is natural log? Well, that's technically log base e. So let me undo here a little bit and say that this is technically log base e. If you ever just see an ln, you read that as natural log, but it's technically log base e. So we don't have anything outside the parentheses to undo. I just have to exponentiate things. And I choose that base e. So now I'm going to cheat again and grab all of you and throw you over there. And I'm going to say e to the power of log base e and e to the power of x. I hope that's clear enough. I can move this e a little bit taller. There we go. And now I get e to the power of x is equal to whatever's on the inside of the parentheses. What's in the inside of the parentheses? A negative 4x in this case. So I have a negative 4x, and I did it again. You probably already caught it. You should be giving yourself extra credit if you're finding it before I am. Why am I doing that? The x should change into a y. If you're doing that too, you should let me know in class. Maybe it'll make me feel better if I'm not alone in making the mistake. All right, 4y, there we go. And now I have to get rid of this negative 4 by dividing both sides by negative 4. So you can say e to the power of x divided by negative 4 is equal to y. There's our final answer, which I will then box. And I should be checking my work. E to the power of x over negative 4, e to the power of x over 4. I mean, they put the negative out front. It's okay to put the negative out front, or just in the top, or just in the bottom, but not all of them. One or the other. I should circle that. I did in ink to let me know I checked my work. Again, we're taking the inverse. Switch your x and your y. So this is going to be x is equal to natural log. Well, natural log is really log base e of, I'm not going to make the mistake now, y minus 3. There we go. And I'm going to exponentiate both sides, which means I'm going to write both of them. I'm I'm cheating a little bit here, and you can cheat a little bit as well. You can say it's e to the power of log base e of all that stuff, and e to the power of x. We have exponentiated everything. You can go ahead and cross things off, cross, 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 leaving us with a y minus 3 on the right, and on the left I have an e to the power of x. From here I'm going to add 3 to both sides, and this is going to be e to the power of x, and then plus 3. Notice that the plus 3 is not up here with the exponent, it's down here with the base, right? And this is going to be our y is equal to, and box it, let's see, e to the power of x plus 3. Come on back here. And e to the power of x over, or plus 3. We got it. What about for number 5? Now I'm starting with a logarithm, and I need to somehow get rid of that logarithm. Well, okay, first of all, it's an inverse. So let's switch x and y. So x is equal to log base 2 of x. I almost did it again. I'm going to catch my... You don't get extra credit for that one. I caught it too fast. Log base 2 of y to the power of 3. And technically, there's parentheses right there, but you don't really need them. All right, so exponentiate both sides, which means I'm going to move you to the right a little bit. What base should we choose? Whatever that base is right there. Our base is 2, so I'm going to say 2 to the power of log base 2 of y cubed is equal to 2 to the power of x. So on this left-hand side is still 2 to the power of x. The right-hand side, cross, cross, cross. Everything inside the parentheses, namely that y to the power of 3, is left over. And now I need to get rid of that power of 3. So there's a few ways of thinking about that. I think most people will probably see, oh, I'm going to take the cube root of the right and then therefore the cube root of the left. And you get, I mean, there's a bunch of ways to write the answer, but your final answer should be like y equals the cube root of 2 to the power of x. But you could also write it a few different ways, because if you remember from Algebra 2, if I'm writing the cube root of anything, like let's say q, it's just as a random variable, this is the same thing as q to the power of 1/3. You can treat a root as an exponential, or as an exponent, I should say. So I can also write this as 2 to the power of x to the power of 1/3, because this power of 1/3 is the same thing as a cube root. And then I can multiply these together, and I can say that this is going to be 2 to the power of x over 3, which is also an answer. Both of these are final answers. And there's another cool way to get 2 to the power of x over 3, which we could have done right over here, but we won't know about that rule until tomorrow, where if you take the log of something that has an exponent, that exponent is immediately allowed to be brought down here, and we could have divided by 3 at the very beginning. What that would have looked like is we would have done divide by 3, that 3 would have been there, we would have divided by 3, got rid of the 3, that 3 was moved down here, and I would have already immediately have an x over 3 that I would then exponentiate. So if you're coming back to this homework after learning our properties of logarithms, you'll be like, wait, there's another way to do it. Anyway, and I think I explained that too much, because example 6 is going to be the same number. Like, look at this. I told you that this 3 could come down in front. Look, the 3 is down in front, and it's the same problem. Log base 2 of x. Log base 2 of x. So the 3 just came down in front. This is probably to emphasize a point. I did do this on purpose. I was thinking about how to clarify this point for the next lesson. Check this out. I'm going to divide both sides by 3 first. And I get y over 3. On this side, I get log base 2 of x, which I don't need those parentheses. It's a bad habit. You are going to be moved over there. What base we're going to choose? Base of 2, just like the last problem. So I was just going to say 2 to the power of log base 2 of x is equal to 2 to the power of y over 3. And then from here, you can say cross, 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 and wait, oh my God. I forgot to switch my x and my y again. I go so fast that I keep forgetting that first very basic step. If you're catching me, you're like racking up the XP, right? Racking up, not the XP, but the extra credit. This is really supposed to be x and a y. So that means that I catch it at the very end. I'm like, wait, it should be y equal to something. There it goes. Y is equal to 2 to the power of x over 3. And just like before, we get the same answer. The main thing that I'm trying to prove to you by showing you problems 5 and 6 is you are allowed to bring this 3 down here to the front and make that your first step. I'll show you more in our next lesson how that works. Properties of logarithms. All right, number 7, I need to get rid of this plus 3 by subtracting 3, and I'm going to switch this into an x at the very beginning. So x is equal to 10 to the power of y plus 3, then subtract the 3, so I get x minus 3 is equal to 10 to the power of y, and then I'm going to, we are not exponentiating, we're trying to unexponentiate, we're trying to undo this power. And we're using that property that I was talking about before. How can you bring this 3 down? How can you bring a power, this variable? This variable can come down if you take the logarithm of each side. So here's what I'm going to do. I'm going to cheat a little bit. I'm going to move you to the right. I know that you don't have technology. You might have to write this as a whole second line, but I don't want to do that. And then I can write log of the right side and log of the left side. And you can choose any base that you want. What do I want down here? Well, I want that same base. So I'm going to choose log base 10. I'll write it to be pedantic, but just to really show what I'm doing. Because, again, this is asking the question, what power does 10 need to be raised to get to 10 to the power of y? Well, it needs to be raised to the power of y. So this is essentially all crossed off, and you get y by itself. Maybe do that in a second color. And on the left-hand side, you have log base 10, which is... Wow, that bell is really loud. Log of no base of x minus 3. That does need to be in parentheses, otherwise it's going to assume just the x is in parentheses, whatever's next to the logarithm. And we'll box that and we'll check our work. Log of x minus 3. Where have I not checked my work in a long time? Log of x minus 3. Those are the correct answers. Notice they're both the same answer. It's y equals 2 to the x over 3, y to the 2. Yeah, sorry. Y equals 2 to the power of x over 3. Y equals 2 to the power of x over 3. We did get those correct. I apologize for not checking my work for a while. I have a few more minutes before I have to go to basketball practice. I'll do the next video in a sec here, or I'll just continue it later. Again, switch your x and y. X is equal to 10 to the power of y over 3. All right, we need to, everything is stuck up here in the power. So the only thing that we can do to both sides is to take the log of everything. So I'm going to move you to the right, and I'm going to take the log of the right and the log of the left. What power or what base do we choose down here? We want to match this power, or this, I keep saying power, this base. So we're going to choose base 10, which again means you don't really have to write it. So on the left-hand side, this is really log of x, and I don't have to have a parentheses. And then on the right-hand side, you can say cancel, cancel, cancel for that same rationale in the last problem, and this is going to be y over 3. To undo that divide by 3, you're going to multiply by 3, and that's the answer. 3 log of x. Sometimes I do a cursive L. I'm supposed to be doing that more often because I know some people read this as 10g. So, like you can see, that's 10g and that's log, right? They look really, really similar, but if I do log like that, you'll never confuse that for a 10g. I hope that makes sense. Anyway, there's my final answer. I should box it, check my work, and I get to basketball practice. So 3 log of x. Ooh, interesting. Yes, that is correct, because remember what I said. Whenever you take the log of a function, this power is allowed to come down in front. I'm weirded out why they put that 3 back up there. You're allowed to do that, but usually this does come down in front, which is what we got. Let's think. Interesting. Yeah, so there's another way to think about this problem that I'll leave you with. Here's another valid first step. Once you get, here, let's come back here. We had x is equal to, and I'll give some space, 10 to the power of y over 3. Instead of taking the log of both sides, this is what you could have done, and it would get you that other answer. What if I take both sides to the power of 3? You're allowed to do that. That would make this an x cubed on the left, and on the right-hand side, this would make this a, check it out, if I multiply 3 times y over 3, the 3 and the 3 would cross cancel, leaving you with just a y. Remember, a power to a power means multiplication. So this would give you 10 to the power of just y. And now I could do log base 10 to both sides. Check it out. Ready? Log base 10 of the left, or sorry, of the right, and log base 10 of the left. And you can again say cancel, cancel, cancel. Y is equal to log base 10, which means I don't write anything, of x cubed, and that is another way to do this problem. So there's 2 different paths that you can take, and these are the same answer, which again I will review in our properties of logarithms lesson next time. I'll leave the video here and pick it up in a sec. Bye.